Okay, in our Spire tutorial this time, what we're going to be taking a brief look at is doing inlays. And the type of inlay that we're going to look at is, let's say I am creating a top for a box and I want to put a metal inlay into it, or acrylic, or whatever material I want to do. So I want to have a pocket cut down into the top of my material that a piece of metal or acrylic that I've cut out into a particular shape will fit into it is really closely and be that same exact shape. That's the type of inlay we're looking at today. We could also do the male type inlay or the female type inlay. The male type would be the part that goes in. We can do both parts together, but we're just going to look at that female inlay today as laying in like a piece of metal or acrylic into another material. So I've set up my size of my piece here, and whatever the size of your pieces that you're looking at is what you want to do. And I'm going to import my DXF file in this case. So I'm going to bring in the vectors, and the vector I have in this case is a DXF. It could be from AI files, Adobe Illustrator files, or you could bring in any bitmap that you wanted and transform it, but I already have a file that I want to use. So I'm going to go to under File, Import Vectors, and I want to bring in my file, which I have found right here already, Dear Family number 5. Okay, and now since all my vectors are outlined, I'm going to align it to be centered in my piece as well. So I go down to Transform Objects, go to the End button, which is Align Selected Objects, and I want to center it in my material. So there's one button I can click to do that. And now we're centered in our material. Okay, so now that's all our basic things from Aspire that you can manipulate size, change rotation, put text in. You can do text, you can do words, whatever you want to do as an inlay. I'm just going to inlay this piece today to give the idea of how it's going to work. So we're going to go up here to our 2D view control, go to Switch to Toolpaths tab, and that brings up our Toolpaths menu bar on this side, because this is what I'm going to inlay. So now we're going to go over here to the Toolpath Operation to the Inlay Toolpath. And that brings up the type of inlay we're going to be creating. The male parts, which are just going to be a straight inset or a stepped inset. Straight would just be the single piece that goes in. The stepped means that part of it would come down lower, so it would sit inside. You would cut that piece out, and then the middle part would go deeper in the material or all the way through. And then we have our females, which are just a simple pocket or a hole, a pocket that goes all the way through the material. So I'm just going to pick a pocket in this case, because I'm going to assume that my thickness of my material is at least ½ an inch, maybe bigger, and my metal thickness, 14 gauge metal, is about 0.079 inches. So I'm going to pick pocket. Now we're just setting up your toolpath in this case. So I want to start my depth. In this particular case, my cut depth is going to start from the top of the piece. So that should start at 0. And the depth I'm going to go is the depth of the piece that I'm putting in. In this case, my metal again is about 0.079, 0.080. So I will leave that's my depth here. If it was a piece of acrylic, a 1/4 inch piece of acrylic, if it was 0.125, then your depth would be 0.125. If you're doing a stepped cut, there will be 2 menus in this case for the male part. The first cut and then the second part. See, we have the first depth here that we're cutting, where your start depth is, and then this will be the whole part that goes down through. Okay, then the thing you have to kind of think about here is looking at how big your piece is and what your tooling is going to be. I'm just going to use my 1/8 inch end mill in this case. Generally an end mill is going to work well. You can use some different shapes here, but an end mill will work the best for doing inlays. You can select or you can edit your tool pass, your diameter, your pass depth, the step over values. You want to be probably 40-50% for your step over, maybe even up to 80%. You get a better finish when it's 40-50% than 80% will go faster. The bigger your step over is going to be. Spindle speed and feed rate is all dependent on your materials and on your tooling, so you want to make sure you're checking that out from your information, from your tooling information, from the place you buy your tooling from. What kind of speeds, what kind of feed rates should you be using with the type of bit you're using in this case. So for us, our spindle speed at 16,000 and 233 right now is a good feed rate for material. Again, depending on if we're using an oak or a maple or a pine or a spruce or a plywood, that value would change. And we would look that up. Okay, and we click OK. Then we can change our passes, and that's all based on our depth we're going. We're not going very deep in this case, so one pass is going to work. And the other biggest thing to take a look at is down here at pocket allowance. You will want to give a pocket allowance. It means it's going to cut the pocket a little bit bigger, whatever size you say, bigger than what your actual piece of material is. If you don't put a pocket allowance in, it'll be exactly the size of your inlay, which means that it will be very difficult to get it in. So giving it a little bit of allowance will make it a lot easier to put that in. Now, if you want it to friction fit in, you want a very small allowance. But you still probably want more than 0 because it'd be exactly the same size and wouldn't fit. I know we've used some this year, and we set a pocket allowance of 0.05 inches, and that worked really well. Good idea to ramp your plunge moves as well, mainly because it just isn't going to try and drive in, especially if it's deeper. It's going to go in a little bit and then start your cut. In this case, it's not real deep, so it won't really matter, but it's a good practice to be used to. It's easier on your tooling. And then we click calculate, and we can see what it's going to look like. In this case, and I can reset preview, preview all tool paths, and it'll show me what my object is going to look like when it's done. Now, the one thing I know probably in this case, even with an 1/8 inch bit here, is that my tines on the deer antlers aren't going to be quite long enough to get to the end on the document, on the picture itself. So I might have to go in with a Dremel tool or some other tool and lengthen a couple of these antler points a little bit for that to fit, and probably down here in our grass a little bit as well. A couple ways that we could fix that is to make our object bigger, put a bigger piece. In this case, there's a lot of detail, fine detail here. Or we could also put a smaller tool in. If we change our tooling down to a 1/16 inch bit, if you have a 1/16 inch bit for your outer, or you could even do this on a mini mill type situation, you can export right to, for example, for us, it's a Roland MDX 40A. We can export right to that machine, and it would cut that. If it was a small enough piece, I could go down to a 1/64 inch bit, just depending on what your tooling is for your router. And then we can also go ahead and close that and then go check on our summary of all tool paths to see that that would take, for this particular size, about 4 minutes to cut this pocket in. So if I'm cutting this out on a plasma cutter on my 14 gauge metal, I can be able to put this in when this is completed in about 4 minutes. So it's a really useful tool for making really nice standouts on your projects. Nice metal inlays or acrylic inlays into wood or into other substances as well.